Hi, it's Only Like Matters here, and today we will continue our efforts and finish what we started in terms of scientific experiments around the moon. There are 3 biomes on which none of our probes making seismic or gravitational measurements has ever landed. We want to rescue 3 Kerbals stranded in moon orbit. You can notice that the 3 orbits are completely different, which adds challenge to the mission. Since I don't want to leave any debris behind, I have to find a way to eliminate them by dropping them on the moon, for instance. Let's talk a bit about the ship we are going to build to rescue our 3 unfortunate Kerbals. We need to board 3 Kerbals and provide life support for, well, let's say 3 weeks to 1 month, just to be sure they won't die. We need a ship with a docking claw. With the claw we can capture a pod, deorbit, release the pod on a suborbital trajectory, then accelerate to get back to orbit, and we need a pretty good amount of delta V to perform these operations, making rendezvous and several inclination changes. We already need around 1500 meters per second of delta V to make a translunar injection and something like 400 meters per second to circularize on the moon. The final design of this vessel will be this one. Well, it's our first ship with nuclear propulsion. 3 Kerbals can take place inside the pod. They have oxygen, water and food for 30 days. We have a lot of monopropellant for precise maneuvers. There are solar panels, a few batteries. There is obviously a docking claw, and last, there is also a probe and an antenna for the remote control of the ship. This vessel will be launched with nobody on board. Our communication satellites around the moon will be extremely useful. Enough talk, let's launch this rocket! The core stage is dropped beyond orbit. We want no debris left in space. We are not in a hurry. I plan the translunar injection maneuver to match the moon in my orbital plan. TLI has been done, we'll circularize and match the inclination of our first target in the same maneuver. Then we execute the first rendezvous. When getting close to the first wreckage we want to dock, I use the same technique I demonstrated in the Artemis challenge video. I refine the trajectory by aligning the target's vector with mine. I aim in the opposite direction to the target's vector, considering my retrograde vector. Look how the two markers align. I warp a bit to get closer to the wreckage we are going to rescue, and you can notice the two markers moved away from each other a little bit. So I repeat the retrograde vector technique. This is probably my favorite maneuver in the game. I found it practical and very enjoyable to accomplish. Let's warp again to move closer. In the map view you now see there is a 0 km distance at the intersection, so the remaining maneuvers are going to be very easy. I change my orientation to prograde and finish the alignment with the target with the SS thrusters. Ta-da! This was all too easy. As making a direct transfer with the claw is not very roleplay, I EVA Tedji and make him board the command pod. We move on to the next maneuver. We want to deorbit the wreckage and align our inclination with the second craft to be rescued. Then we warp and execute the maneuver. Just before releasing the pod, we transfer food, water, monopropellant, oxygen, and nitrogen to recharge our supplies. I must say I'm a bit surprised. I did not expect the amount of monopropellant remaining in the wreckage to be that large. Let's pause here and analyze the situation. We want our ship to make a rendezvous with our new target. The idea is to find a new orbit so that we kind of automatically make this rendezvous happen. We could, for instance, first increase our periapsis to a given altitude, second, tweak our orbit at its new periapsis so that our apoapsis matches the target's periapsis. What our vessel would do is make half an orbit to its new periapsis, then make a full new orbit, then make a half of the new orbit, which makes a total of 3 halves of the new orbit, and the rendezvous would automatically occur. We already know the duration needed for our target to reach its periapsis. It's 2 days, 5 hours and 40 minutes. Our starting apoapsis, our new apoapsis, which is exactly the periapsis of our target. From the Delta V map episode, we know the gravitational parameter and the radius of the moon. Well, we have everything we need to build a spreadsheet. Everything we know has been put here, and we use the orbital period formula to determine our first and second orbit periods. We can play with the periapsis value in pink to find a duration which matches the time needed by our target to reach its periapsis. And we find an acceptable value with 4 seconds precision. We can now apply this magnificent plan. The orbit modification has been done. We don't have any intersection yet because we need to go beyond our apoapsis before the marker updates. You can see now that we do have very close positions. The rendezvous is going to be quite easy. oops, our relative velocity was a bit too high, we have to repeat our approach. No big deal. And we have docked. Haha, I like it when a plan goes smoothly. We EVA Pedas and make him join the command pod. Then we transfer some resources from the rescued wreckage to the vessel. You are now well aware of the next steps. We are going to both deorbit the wreckage and change our inclination to match the one of the last wreckage to be rescued. Actually, changing the inclination is not mandatory for the rendezvous as long as the deorbit maneuver is done in the orbital plane of our target. Last resource transfer before releasing the pod, and bye bye little pod. We now accelerate to raise our periapsis to match our target's orbit. We use the RCS thrusters because it's a small acceleration, and we want to preserve the number of ignitions of our atomic engine. Then, at the periapsis, we find an appropriate apoapsis value so that we can intercept the course of our target in one orbit. I warp to the periapsis and start the retrograde burn. I deactivate the node to monitor the intersect point in real time. When close enough, I finish the maneuver with the help of our RCS thrusters. We have a 0.8 km separation, which is good enough to make a rendezvous. I warp again and I refine the trajectory with my retrograde burn trick. Third docking, yeah, it was the last one. As usual, we secure our Kerbal in the command pod and we transfer some resources. While we have plenty of Delta V left, we will go back home and drop the rescued pod in Earth's atmosphere for a change. The huge quantity of Delta V left will also allow us to help with braking during the atmospheric re-entry. and we have splashed into the ocean. We gained a few science points from returning a vessel from a suborbital trajectory around the moon. Our Kerbals gained 1 star, and we validated many contracts. Next time we will do some cleaning regarding the probes we launched, and we will make a few manned landings to get the remaining experiments and EVA reports on biomes we have not explored yet. Take care and don't forget to test is adopt.